Alright, we are in Algebra 2. Today's date is Wednesday, November 20th. We're doing the fall benchmark practice. It's all about polynomials. Let's go through this. Number 1, we need to rewrite each of these in standard form. A lot of you have these problems done, so I'm expecting you to correct your work and do it correctly if need be. So again, you're going to make your area model, also known as the tabular method, and you're going to say on the top or on the left, it doesn't matter, 3x plus 2 and 3x minus 2. There is a shortcut, and you guys can see it at the very end. 3x times 3x is 9x squared. 2 times 3x is 6x. I have a negative 6x, and I have a negative 4, which means if I add up all of the area, a positive 6x and a minus 6x, that makes 0. So my answer here is 9x squared plus 0x, so nothing, and then minus 4. That is the final answer in standard form. Again, standard form means the powers are decreasing. It goes power of 3, power of 2, power of 1, power of 0. Again, power of 0 means it's a constant term. If you guys feel like I'm going too fast, then please raise your hand. Otherwise, I can't tell. It's hard for me to circulate the room while I'm also teaching. And I'm going to assume I can go fast for the first bit because I think most people have tried these. So again, this is 3x minus 2, 3x minus 2. So again, make your area model. When you make your area model, you can do 3x minus 2 on the top, 3x minus 2 on the left, and then just multiply them out. So 3x times 3x is 9x squared, minus 6x, and positive 4. From there, you're writing out the area as 9x squared minus 12x plus 4 for your final answer. No questions thus far? You can turn the fan towards you and on if you want, but I would prefer it off if it's pointing towards me.
I turn it off.
Thank you for turning it off for me, or turning it. For letter C, it's very similar. By the way, the shortcut, whenever you have conjugate pairs, is you square the last term, or square the first term, square the last term, and then just choose the sign that's in between, so it's a minus sign. The shortcut for this one is you square the first, double the product, square the last. And this one is very similar, where you square the first, double the product, square the last. So if I want to use that shortcut, the shortcut tells me square the first, 9x squared. Double the product, well the product is 3x times 2 for 6x. Double 6x gives me 12x. And square the last gives me 4. Again, square the first, double the product, square the last, or you can make your area model. And let me do that really quickly in case you like the area model. The area model means you're drawing out your rectangle. In this case, it's a square. On the sides, you're labeling it 3x plus 2 and 3x plus 2. And then you're labeling all the insides as 9x squared, 6x, 6x, and 4. Adding up all the area does indeed give you this answer up here. Notice 6x and 6x combines to 12x, and I have the 9x squared and 4 as well. Sorry. And then finally for D, this one is a little bit trickier. Again, you can use a shortcut twice, or you can actually go ahead and just pay attention. Hey, this is 3x plus 2 squared, this is 3x plus 2 squared, this is 3x minus 2 squared. You can write that up here as well. This is the same thing as 3x minus 2 quantity squared, which is what this is asking for. So go ahead and do what is C minus B. And I should box my answer for part C. So if I rewrite them, C is really C minus B, and part C was 9x squared plus 12x plus 4, and then I'm going to subtract in parentheses here 9x squared minus 12x plus 4. Minus 12x plus 4. Whenever you subtract polynomials, remember to distribute your negative. This negative right here is going to be distributed into each of these three terms, which means I'm really doing minus 9x squared plus 12x and minus 4. Combining like terms, 9x squared minus 9x squared, those two cancel out. I have a positive 12x and another 12x, which means I have a 24x. And a positive 4 minus 4 is 0. My final answer here is just 24x. I see lots of pencils writing, which is why I'm pausing. I'm giving you guys time to make sure you understand D, at least have it written down. If we do not finish the video in class, I will finish the video on my own time, and I'll have it up sometime today, hopefully earlier rather than later. I'm moving on unless someone wants me to spend more time on number 1. All right, number 2. We have this function, and we know that when I plug in -3 for each of these x's, my answer is 0. So that means I can plug in every single number, I can plug in -3 into each of these x's, and I should get 0. That helps us because I know what one of the factors is. What is one of the factors of this polynomial? You take the opposite of the -3 and it becomes +3, and I therefore know that x plus 3 is one of the factors. If q of -3 gives me 0, x plus 3 must be one of the factors. I take the opposite number, it's a +3, that means x plus 3 is a linear factor of this polynomial. Another way of saying that is I can do synthetic division now to figure out what the remainder is whenever I divide this polynomial by x plus 3. So synthetic division means I'm going to be putting the opposite sign, or using this same number, -3 in our box on the top left, and then I'm going to write down my coefficients, 1, 10, 3, and -54. Draw your line, giving yourself space right here to write some extra numbers, and then we're going to be doing synthetic division. Let me review why we're doing this. We need to completely factor this polynomial. One of the factors is x plus 3 because when I plug in -3, my answer is 0. If you take the opposite, that means that the opposite, when you plug it in x plus whatever that opposite is, that will be a factor. Ellery.
Are you supposed to switch the sign?
You are supposed to switch the sign from a +3 into a -3 for synthetic division. I agree.
Wait, but doesn't it cause that 3 is negative, so it should be positive?
This 3 up here, actually that 3 actually gets switched twice. Once to get to the linear factor and then once again to get back here. So it's actually the same number. All right, let's do synthetic division. 1, bring it straight down. 1 times -3 is -3. Again, I multiply this 1 and -3 to come to the diagonally top right. Then I add straight down. -3 and 10 makes a 7. 7 times -3 now is -21. Add straight down, I get -18. -18 times a -3 should be a positive number. 8 times 3 is 24. Carry that, it's a positive 54. You will have a calculator on the entire benchmark. So if you want to grab a calculator now to practice, you can. Or if you want to use a calculator on your computer, that is also fine. But notice that our remainder is 0, which is what should happen. It said that this is equal to 0, which is the equivalent of saying that the remainder is 0. This is the remainder, it's 0. So far, we've done it correctly. Our polynomial that we have after we factor out this x plus 3 factor is 1x squared plus 7x minus 18. It's very, very similar to the homework that we've been doing. Use synthetic division, then do ninja star after that to factor it even further. So up to this point, this is how this factors. This polynomial right here has turned into this factor, x plus 3, times this polynomial, which is the remainder after I divide by x plus 3, which is x squared plus 7x minus 18. Now I'm going to do ninja star on this polynomial because I need to factor it one more step. So I can come over here to the right hand side where I have some room, and I'm going to use a normal ninja star. If you want to use an advanced ninja star, it'll work. You only need a normal ninja star. 7, that coefficient goes on the bottom. -18, that constant goes on the top. I need to ask myself, what times what is -18 that also adds to positive 7? Ellery. 9 and -2. There it is, which means our final answer now, I still have that x plus 3 factor, and I also have x plus 9 and x minus 2. This is my final answer. I have completely factored this polynomial. Every single one of these benchmark practice problems is extremely similar to the actual benchmark. I use similar wording, a very similar problem. So if you know this procedure, you know that number 2, I need to use synthetic division to factor. You will have this ready to go for the benchmark.
It's going to be the same kind of problems in the same order.
In the same order, yep. All right, number 3 we talked about briefly. And again, if I'm going too fast, you need to raise your hand and just say, hey, can you give me 30 seconds? But I see some pencils writing, but I don't hear anyone yelling out. So we're going on to number 3. We have the Pythagorean Triple 5, 12, 13, which means 5 squared plus 12 squared must equal 13 squared. Which of the following triples can be generated from that set 5, 12, 13? I'm selecting all answers, so I could have 2 possible answers, 3, or all of them. The way that you do this is you just multiply by any constant number. For example, let's multiply by 2. If I multiply by 2, then I get 10, 24, that's not 24, 24, 26. Is that one of the answers? Oh, that's A. So that's an answer. Let's multiply by 3. Let's see what happens. Multiply by 3. 5 times 3 is 15. 12 times 3 is 36. 13 times 3 is 39. Is that an answer anywhere? It is indeed. Yeah, it's D. B and C are not the answers because there's nothing I can multiply 5, 12, and 13 by to get to those numbers. That's it. Just multiply by a number, usually a whole number, and you should find other triples that can be generated from that one set. On to number 4. All right. So I'm giving you this formula. A squared minus B squared. This is a difference of squares. That factors to A minus B times A plus B. So now I also have a difference of squares. Check this out. I have x minus 2 squared, and then if I square that again, I have to the power 4, and another square. These are 2 different squares. They just look very confusing. So if I take the square root of each of them, the square root of x minus 2 to the power 4 is x minus 2 to the power of 2. If I take the square root of 9, I get 3. Again, if I take the square root of x minus 2 to the power of 4, I get x minus 2 to the power of 2. Whenever I'm trying to do a difference of squares and using the formula, I will always be taking the square root of the first number and the square root of the last number. The way that I take the square root when I have a power is divided by 2. 4 divided by 2 is 2. So if this was to the power of 6, 6 divided by 2 would have turned into a 3. Just divide that power by 2. That's the same thing as taking the square root. So I know that this is going to be my A, this is going to be my B, and I plug it into this formula, and I'm basically done. Here we go. A minus B. Well, that's x minus 2 quantity squared. That's A. Minus B is minus 3. So that was in my first set of parentheses. I'll make them square brackets. That was A minus B. Next, I'm going to do A plus B. So A is x minus 2 quantity squared plus B, and plus B is 3. I have now turned this x squared minus 4 minus 9, x squared minus 2 to the power 4 minus 9, into this form. I need to do a few extra steps now. Ellery.
Shouldn't one of those be x plus 2, so it should be x minus 2? Isn't it like that thing where when it's squared, you take the
It's conjugates.
sure.
So I think you're kind of correct. This is the correct answer because A is being plugged into A and A. A is x minus 2, x minus 2, x minus 2. The difference comes between the minus 3 and the plus 3. That's where this conjugate pair happens. Yeah, good question. Now we have to do a little bit more math. We have to factor this even further. Well, what is x minus 2 quantity squared? Actually, I don't know if I can go any further. Let me write equivalent forms because I'm pretty sure this is a multiple choice answer. If I have anything squared, it's the same thing as squaring the first, doubling the product, squaring the last. So on this one, I'm squaring the first, x squared, doubling the product. Negative 2 times x is negative 2x. Doubling negative 2x gives us negative 4x. Square the last, negative 2 squared is a positive 4. And then from there, I still have the minus 3. That was the first set of parentheses. This set of parentheses right here turned into this set of parentheses. Again, square the first, double the product, square the last, and then there's the minus 3 that I just copied down. I'm doing the same thing over here. Square the first, double the product, square the last. This is going to turn into x squared minus 4x plus 4. And this is going to be plus 3 instead of minus 3. Here we go. X squared minus 4x plus 4 plus 3 instead of minus 3.
Why is this not like any of the other problems we did in our unit? Like, I feel like when they were not very complicated. When we did this stuff about.
It's because we haven't gotten to this material yet. Eureka Math does a slightly different pace than us. We learn things that Eureka Math doesn't, and they learn things that we don't. All right.
It's better.
Definitely different. So, giving this a little bit more simplification, we have x squared minus 4x plus 1. Again, 4 minus 3 is just 1. On the other side, we have x squared minus 4x plus 7. So, if you're looking at a multiple choice answer, all three of these are technically correct. These are equivalent forms. I can't factor this one any further, and I can't factor this one any further. You can try doing a ninja star, and it won't work. What times what is 1 that also adds to negative 4? Doesn't work. Same thing with what times what is 7 that adds to negative 4? Just 1 and 7, and there's no way to get a negative 4 from that. All right, so these are 3 possible answers, 3 equivalent forms. You can box all of those if you'd like. All 3 of those are your answers. Let's move on to number 5. Number 5 we've seen almost verbatim. It's just tricky is all. So we know that h is a polynomial, and we know that we're trying to find something that indicates 6 is a 0. So again, question, Oscar. The benchmark does go into Aries, yes. Not as a test, but as a homework score. So it can affect your score up to 0.5%. Yes. Well, rather, Heidi Torres is going to compare us to Colville, but I will also compare you to Colville. It's more of a pride thing with me. So, behind Oscar, there is a reminder for what zeros are. Functions have zeros. The zeros of the function by Oscar's head is 3, positive 3, and positive 5. Again, I will repeat that. The poster by Oscar's head, the zeros are positive 3 and positive 5, even though it was in the factored form x minus 3 and x minus 5. You switch them in the factored form. Which means, if I'm looking for 6 to be a 0, I'm looking for something like x minus 6 as a linear factor. So right away, we can automatically circle D. But we're selecting all answers that can apply. So it's not C, because that is the wrong sign. What about some of these, A and B? Let's analyze this. If I plug in 6, that gives me 0. If I plug in 6, that gives me 0. Does that sound right? Give me a thumbs up or thumbs down on this one. Everyone take a guess. A, thumbs up. I think it is indicating that 6 is a 0. Thumbs down, 6 is not a 0. The correct answer is thumbs up. That is a 0. Again, you switch the sign from the linear factor and it becomes a positive 6. So A is also an answer. It's another way of saying that 6 is a 0. This one does not make sense because you have to have a remainder of 0 in order for it to indicate something. This is saying that this is basically saying that x is not a factor. Or that x minus 0 is not a factor. And then E and F. One of those two is correct, one of them is incorrect. An x-intercept. And you can take a look at Oscar's poster as well. An x-intercept. they should also be the switched version of whatever the factor is. Take a look at the zeros in the top left. The opposite of negative 3 is positive 3, which is why you have an x-intercept of 3, 0. The opposite of negative 5 is positive 5. That's why I have an x-intercept of 5, 0. So everyone shout this one out. Let's see how many voices we can hear. Is it E or F? It is indeed E. I will be leaving up those posters. They kind of help you, but you have to know what you're looking for when you're looking at those posters. Let's go on to number 6. Add and simplify by rationalizing the denominator. In order to add fractions, as a review from 7th and 8th grade, I need to have like denominators, which means I need to multiply the left-hand side by 3 over 3 and the right-hand side by the square root of 5 divided by the square root of 5. That was a bad square root. When I do that, the left-hand fraction becomes 15 in the numerator, 3 square root of 5 in the denominator. So 15 in the numerator, 3 square root of 5 in the denominator. And I'm now going to add that to square root of 20 times the square root of 5. Whenever you have square roots that are being multiplied, you can create them, or you can put them all under the same radical. This is going to be the square root of 20 times 5, or if I have 20 nickels, I have $1, so it's the square root of 100. 20 times 5 is 100. And again, that's all going to be divided by 3 square root of 5. It should be the same denominator as the left, because that was the whole point. We were rationalizing the denominator. We were missing a square root of 5 on the right, so we multiply by square root of 5 over square root of 5. We're missing a 3 on the left, multiply by 3 over 3. From here, we can now add, and we can simplify at the same time. Everyone can shout this one out. The square root of 100 is what? 10. So I'm really doing 15 plus 10 on the top, so I have 25 on the top. And on the bottom, I have 3 square root of 5. While this is an answer, it has not been rationalized, or the denominator has not been rationalized, which means in order to rationalize the denominator, I now need to multiply the top and bottom by whatever this square root is. So in this case, I'm going to multiply the top and bottom by the square root of 5. So square root of 5 times the square root of 5. When I do that, I'm going to get something that looks like square root of 5 quantity squared. I'll have 2 of these square roots of 5s. From there, the square root and square will cancel each other out, and I'm just left with 5. So this is really going to be 3 times 5. 15. Colby. All right, yeah, I'm guessing other people have the same question. How did we get to 25? The square root of 100 is 10. 10 plus 15 is 25.
Wait,
Question, Ellery.
what did I think? You might have a square root of 1.
It does, yeah. The numerator is now going to be 25 square root of 5. And I'm not done. Wait, there's more. I can now divide the top and bottom by the greatest common factor. Yes, divide the top and bottom by 5, and I get 5 square root of 5 over 3, which is the final answer.
I feel like we haven't.
Rationalizing the denominator, this next unit assumes that you know how to do that. So I'll have to do some scaffolding to make sure that you know how to do this in order to do the next lesson. All right, we're on to the next page. Make sure you have this copied down and you know how to do problems like number 6.
So, this is being structured over 2 days?
The benchmark is going to be Thursday and Friday.
Is it that long?
It is that long. It's this many questions. So we have how many questions on the practice? We have 14 questions on the practice. That means there are 14 questions on the benchmark.
So are we strictly going to do a certain amount on Thursday?
Do as many as you can. If you finish on Thursday, then you can have study hall on Friday. But actually try. If you bomb it and then we do really bad compared to Colville, I'm going to be very sad.
So what if we all like finish early on Friday?
Yeah, that sounds fun.
Wait, what if
Wait,
we do better
we're
than
not
Kevin,
having
we also
class
have
on Friday.
For sure, yeah.
We're not having 6th period on Friday.
Oh, we don't?
We're having 2 weeks classes.
Okay, so that means if you do not finish by Thursday, then you guys just need to finish over Thanksgiving break. But hopefully you just finish on Thursday and you have no homework, right?
Because we'll have 7th periods probably. They'll finish at like
What's happening on Thursday?
Thursday, isn't that Thanksgiving?
No,
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 Friday.
on Friday.
On Friday.
On Friday is the Thanksgiving.
Wait, when are we doing the drunk driver thing, Mr. Siddell?
That's Thursday.
Tomorrow doing
That's
what?
tomorrow.
What period?
Arrive alive. I think it's advisory.
Oh.
All right, so number 7. The quotient of x squared minus 9 over x minus 3 is x plus 3. What it did for you, Sam, is it did synthetic division. It said, hey, I did the synthetic division. I switched the sign from a -3 to a +3. I did that, and I did all the math, and I found out that my answer was x plus 3. What you are responsible for doing is doing synthetic division on A, then on B, and then finding the pattern to figure it out on C. C is a general case. I don't know what number I have here. It's just A. It's not 27, it's not 3, it's not 81, it's not 3. It's just some general number. So, let's try it out. Synthetic division. This -3 turns into a +3. Write it down with me. That goes in the top left in a box. You're going to have a lot of placeholder values. Let me write this one out before I even begin my synthetic division. I'm not writing out my synthetic division yet. Before I do that, this is x to the power of 3 plus 0x squared plus 0x minus 27. So now it makes it much easier to figure out what my coefficients are for my synthetic division. My coefficients are 1, 0, 0, and -27. Now let's actually carry out our synthetic division. The 1 comes straight down, that's 1. 1 times 3 is 3. 0 plus 3 is 3, then I multiply again. 3 times 3 is 9. 9 plus 0 is 9. 9 times 3 is 27. -27 plus 27 is 0. This means my final answer, this would be my remainder, this would be my over x minus 3. So there's no remainder. I'll write it down here. No remainder. This is my constant term, this is my x term, this is my x squared term. My final answer here when I do x cubed minus 27 divided by x minus 3 is x squared plus 3x plus 9. While you're doing this, look for patterns. The patterns will help you with part C. Part C is the hardest of them all. We're moving on to part B now. For part B, again, I'm going to rewrite this out. X to the power 4 minus 81 is the same thing as x to the power 4 plus 0x cubed plus 0x squared plus 0x minus 81. Here I go. Oh, I need to actually do my synthetic division. My coefficients are 1, 0, 0, 0, -81. Which means synthetic division, I bring that 1 straight down. 1 times, oh, I forgot my 3 out to the left-hand side. Again, I need to switch the sign from a -3 to a +3. 1 times 3 is 3. 3 plus 0 is 3. 3 times 3 is 9. Bring it down. 27. Bring it down. 81. Bring it down, and it's 0. I have no remainder yet again. My answer is 1x cubed plus 3x squared plus 9x plus 27. All right. We can actually just brute force our way through part C as well. Although if you find the pattern, it helps you immensely. So I'm going to rewrite this in terms of, or just like I did with A and B. So if I'm rewriting this, I have x to the power of 5 plus 0x to the power of 4 plus 0x to the power of 3 plus 0x to the power of 2 plus 0x minus a to the power of 5. Which means my coefficients in my synthetic division are 1, 0, 0, 0, 0, negative a to the power of 5. I take the opposite. Instead of negative a, I have a positive a up here in the top left. It's still synthetic division, but now with variables. 1, bring it straight down, it's still 1. 1 times a, I think we can all agree, is a. 1 times anything is whatever that anything was. 1 times a is a. A plus 0 is a. A times a is a squared. I think you guys can see where I'm going to start to go with this. Again, making sure that everyone is understanding where we're going. Synthetic division, I bring 1 straight down. 1 times a is a. A plus 0 is still a. A times a is a squared. This power tells you how many times I've multiplied a. Which means I'm going to have a squared, and then it goes a to the power of 3, a to the power of 3, a to the power of 4, a to the power of 4, a to the power of 5. Ooh, a to the power of 5 and negative a to the power of 5 is 0. And there is our basic answer. This is our constant term. We don't have any x. We add the x here, x squared there, x cubed there, x to the 4th there, and our final answer, we'll write it down again, is x to the power of 4 plus ax to the power of 3 plus ax, or a squared x to the power of 2 plus a to the power of 3x plus a to the power of 4. You guys got this. It's synthetic division, but this time with variables.
That's just long.
It is.
Well, that's long. That's long.
But you guys got this. It's going to be a very, very similar problem. Think like a teacher right now. Put on your teacher hat. If Mr. Sindel had to change this problem somehow, how would he change this problem so that they're different numbers?
You just change the 3 to like 4.
That's basically exactly what it would be. Probably made it easier rather than harder though. You were making that problem harder.
So you make it the 2 to 3 and 2.
So if you can think like a teacher, you can already solve the actual problem that's going to be on the benchmark. All right. We have a polynomial that has the following properties. The zeros are at negative 2 and 6. Negative 2 has a multiplicity of 2. This means, let me analyze each of these lines. If the zeros are negative 2 and 6, that means my factors are x plus 2 and x minus 6. If negative 2 has a multiplicity of 2, that means this x plus 2 is to the power of 2. If 6 has a multiplicity of 5, that means that this x minus 6 is to the power of 5. If 1 is the leading coefficient, that means that both of these coefficients have to be 1. What times what is 1? Well, 1 times 1 is 1. That means we have essentially solved what this function looks like. It looks like this. X plus 2 to the power of 2 times x minus 6 to the power of 5. So I consider that problem to be one of the easier problems on the benchmark because you literally just switch the signs and make that a linear factor. Negative 2 turns into a positive 2, 6 turns into a negative 6, and then you put the correct power. Power of 2, power of 5, done, right? And I'm not going to make this anything other than 1. The hard part now is part B. Part B is asking you, you need to have the same zeros with the same multiplicities. So that means I cannot add any additional zeros. And that actually is a straightforward way of solving this problem. What is this 0? Switch the sign, essentially. Or set this equal to 0. X will be equal to negative 4. Again, you set whatever this thing is to 0. Do it with me. x plus 4 equals 0, and then you solve. After you solve, you subtract 4 from both sides, minus 4, and you get x is equal to negative 4. This adds on a 0 of negative 4, so it's not a. Check that out. Negative 4 is an extra 0, so that doesn't work. Let's try the next one.
What do you mean there's an extra zero?
What? Say again?
Wait, what do you mean there's an extra zero?
So the whole problem is asking you, you cannot add any extra zeros. You have to have the same zeros. The zeros were negative 2 and positive 6. Well, now we just added another 0 of negative 4. Look, we multiplied our original function. This is f of x, this is f of x. We took our original function, we multiplied by x plus 4. You can't multiply by x plus 4 because you added on this extra 0. This negative 4 is an extra 0.
So it can't be negative?
So it can't be anything. If this is an answer, then that is not
So it
okay.
has to equal 0.
This has to equal nothing. This can't work. This has to equal does not exist. That's the only way for this problem to work. Let's try the next one. If I set this equal to 0, x minus 4 is equal to 0, that means x is equal to 4. Again, that does not work because you've added on another 0. The only zeros you may have are negative 2 and 6, not 4. 4 is an extra 0. That does not work. Let's try another one. Set x squared minus 4 equal to 0. X squared minus 4 equal to 0. Well, if I do that, I'll have to be a little bit careful with this one because it has a square in it. I'm going to add 4 to both sides. Let me zoom in here so we can see. If I add 4 to both sides, I now have x squared is equal to 4. If I take the square root of both sides, I'm left with x is equal to plus or minus 2. Again, that's even worse. I added on 2 extra zeros, a negative 2 and a positive 2. It's definitely not C. I mean, by process of elimination, it is D. Let me explain why it is D. X squared plus 4. Let's set this x squared plus 4 equal to 0. X squared plus 4, set that equal to 0. Subtract 4 on both sides. X squared is equal to negative 4. Hold the phone. Check this out. Anything squared is always positive. This will never happen. The answer here is does not exist. Actually, the answers are imaginary, but we're assuming we're in complex, or we're not in complex land, we're in real land. So the answer here is there are no extra zeros. So this one has no extra zeros. No zeros. That's why it's the answer. You have to choose the one that has no zeros. This has no zeros. Aurelia, can you please take notes?
Wait.
Yeah.
I think Aurelia needs a hug. Permission to give him a hug.
Permission denied.
Just trying to morally support a friend.
Thank you for doing that. All right, we're moving on to the next question. Bless you. All right, number 9 is asking for the zeros on this list. Again, the zeros mean I set all of this to 0. So mark it with me. Set this problem to 0. Please don't use that word.
I said jit. I can't say the real word.
Set this equal to 0, and by the zero product property, set each of these linear factors to 0. So there should be 3 separate problems. Obviously, 3 cannot equal 0, so you don't have to worry about 3 equaling 0. But I do need to say x plus 1 equals to 0. That's the first problem. 2x plus 3 is equal to 0. X minus 4 is equal to 0. And then I solve. Well, subtract 1 on both sides. X is equal to negative 1. Subtract 3 on both sides, I get 2x is equal to negative 3, and then divide both sides by 2, x is equal to negative 3 halves. Finally, add 4 to both sides, x is equal to 4. We just found all the 3 zeros of our function. So what are the zeros? Here they are. But what are they in order from least to greatest? So negative 3 halves is the most negative, so I'm going to do negative 3 halves, then negative 1, then positive 4. So my correct answer here is negative 3 halves, -1, and 4. All right, so I'm still talking about this function up here. I'm still talking about 3 times x plus 1 times 2x plus 3 times x minus 4. This is positive and negative intervals of polynomials. This was lesson, what was it, like 4-2 or 5-2 is the second one. The way that we do this is we make our number line. Make your number line and then mark your zeros. Your first zero is -3/2. Circle it to let you know that it is a 0. Then -1, circle it, that is a 0. 4, that is a 0. We need to choose test values in between each of these intervals to see what happens. If you know the shortcut, this problem is really, really, really easy. And I want you guys to do the shortcut, so I'm going to be teaching it again. Let's choose the best possible values for any of these intervals. I think that the easiest possible number is right here, 0. Let's try plugging in 0. Let's see what happens. So if I plug in 0, I'm plugging in 0 into each and every one of these linear factors. 0 plus 1, 2x plus 3, x minus 4. I'm plugging in 0 into each x. So first, let me ask, is 3 positive or negative? Everyone do thumbs up or thumbs down. Is it positive thumbs up or negative thumbs down? Everyone participate. 3 is positive. Good. Mark it. Then I'm plugging in 0 again. 0 plus 1. Is that positive or negative? Thumbs up, thumbs down. It is positive. When I plug in 0 to 2x plus 3, is that positive or negative? Positives have it. And when I plug in 0, is it positive or negative? Good job, guys. It is indeed negative. Positive times a positive times a positive times a negative. Final thumbs. We have a negative. Which means this interval right here is negative. We haven't done the shortcut yet. Here comes the shortcut. The shortcut says if these linear factors have an exponent that's odd, or if there's not an exponent, because it's the power of 1 is an odd number, that means over each of these values, it's going to switch signs. If it was a negative, it's going to be positive. Then switch again, negative. It's going to switch over the 0, it becomes positive. That's the shortcut. So again, if it was negative here, it's going to be positive because I switched, I jumped over this x. It was an odd power. It's going to be positive, and it's going to be negative. Now we have the intervals of our polynomial. We know if it's below or above the x-axis. So let's read these sentences and mark the correct answer. The portion of the graph located to the left of the leftmost 0. So it's saying this interval that's to the left of this -3/2 is that above or below? Give me thumbs up or thumbs down. Is it above or below? Really quickly. Come on, guys. It's below, so circle below. The next interval, is it above or below? Everyone should be doing thumbs up. It is above. Circle it. The next interval, is it above or below? It is below because it is a negative for this third interval. In your final interval, to the right of the rightmost 0, this final interval, is it above or below? Thumbs up, thumbs down. The thumbs up have it. It is above.
So when it says like the portion of the graph located to the left, like that's just talking. Is it always going to be in order like that? And we can just know it starts with the leftmost interval.
Yes, exactly. It'll always start from left and go right. And then finally, it's talking about end behavior. It's talking about your dance. You don't even need to know your dance. Here's your dance. Your left hand is down. Your right hand is up. You're doing this. So, as I go to negative infinity, this is asking what is your left hand? What is your left hand doing? It's going down. It's negative infinity. And your right hand is going up because this is positive infinity. So as I go to positive infinity, that's your right hand. That's going to just normal infinity or positive infinity. And that's how you do number 9. What time do we get out of here, by the way? 18, okay. Thank you. Yeah, I totally forgot. We'll do 2 tomorrow. 2 random events. Oh, 3, I guess. Okay, and that's all I have for you guys. I will finish the rest of this video at another time. There's only a few more problems left. All right, we're on to number 10. One of the factors of the polynomial, this thing right there, is this. Okay, so it's very similar to one where we're trying to factor, right? Right? P is a product of this and another polynomial. Yeah, so it's exactly that. This one is going to be a little bit difficult because this one we can't use synthetic division on. This one we have to use long division. Again, synthetic division only works when this number is 1, or just x minus 2. This is 3x minus 2, which means we have to use long division. And I mean, I'm apologizing up front because I have taught this, but we haven't been using it because synthetic division is so much easier. So let's use long division. Here we go. Leave some space up here to write your answer, and it's going to be 3x minus 2 goes into this polynomial 3x to the power of 4 minus 8x to the power of 3 plus 7x squared minus 2x and plus 0 technically, because you need a placeholder wherever you don't have a term that is descending, right? So if I didn't have any x cubed term, I'd have to put a 0x cubed here. So I'm going to go through this slowly at first, but then faster and faster, and I'm realizing I'm going to probably write this answer all the way down here. I'm going to need a lot of room, so I kind of made a mistake when writing this practice. And I apologize. All right, let's go ahead. I'm always asking, this term multiplied by what gives me this term? Well, 3 times what is 3? 1. So the answer right here is just going to be 1 something. X times what is x to the power of 4? X to the power of 3. So now I'm going to say 1x to the power of 3. I'm going to multiply that by both of these two terms and write it underneath right here. So here I go. 1x to the power of 3 times 3x is 3x to the power of 4, which is what we wanted. We want to match up this term exactly, and we've done that. Okay, so x to the power of 3 times negative 2 is negative 2x to the power of 3. From there, we're going to switch the signs. We're going to say minus, plus, and then add them straight through. These cancel out. So far, so good. This is going to be a negative 6x cubed. Same thing again. Now I'm asking, what times 3x gives me negative 6x cubed? Well, 3 times what is negative 6? The answer here is negative 2. And what times x is x cubed? X squared. And then I multiply them. I say negative 2x squared times both of those two terms, this binomial. That will give me a negative 6x cubed, which matches up perfectly. And I forgot to bring this 7x squared down. I should have done that, so that's a plus 7x squared. I'll do that now. And now I need to multiply negative 2x squared times negative 2. The negative times negative is a positive, so positive 4x squared. So positive 4x squared. Again, we're going to switch these signs. It becomes positive and then negative. So those cancel out, and 7 minus 4 is 3. So I'm going to just kind of write down here. I know that we're running out of room. So 3x squared. Let's go ahead and actually do the correct step. Bring this down. It's going to be minus 2x. The question again becomes, what times 3x is 3x squared? And the answer is x. I'm starting to go a little bit faster now. Plus x. When I do x times 3x, I get 3x squared. When I do x times negative 2, I get negative 2x. Again, switch the signs. It was a negative and a positive now. Add straight down, that cancels out, and that also cancels out, and I can bring down the 0. I'm just left with nothing, 0, 0, 0. So here's the answer. When I do long division, my factors become, so you need to write it as a product of this and another polynomial. So this I'm going to rewrite, 3x minus 2, and another polynomial, which is this right here, whatever, when I divide. So that's going to be x to the power of 3 minus 2x squared plus x. And it ended up, we didn't need that placeholder value because it was always 0, but it is always important to write those placeholder values. So there is the answer to part A. There is your product, and I'll go ahead and box that. All right, so part B, what are the solutions when I actually set this thing equal to 0? So now what we have to do is we need to actually factor this thing. So what we need to do is we need to factor using a ninja star. Our advanced ninja star, actually, hold on. Before we do that, step 0 is always greatest common factor. So greatest common factor is x in this case. So I'm rewriting this. This is now 3x minus 2 times x, and after I factor out x out, I'm left with now x squared minus 2x plus 1. Okay, now I can ninja star this thing. I don't actually need to use advanced ninja star since there's no leading coefficient here other than 1. So a normal ninja star will work. Let's go ahead and do that over here on the right hand side as an advanced. There's a normal ninja star. This middle coefficient goes in the bottom, -2. This last number goes on the top, 1. What times what is 1? Well, 1 and 1, right? And they both have to add up to -2, so make them -1, -1. All right, so we've factored everything then. This is 3x minus 2. This is x. This is x minus 1, and that is x minus 1. What we need to do now is set this equal to 0, and then find the solutions. So, setting this thing equal to 0 now, that means each and every one of these 4 factors is set equal to 0. So there's 4 problems to do. If I set 3x minus 2 equal to 0, that means I'm going to add 2 on both sides, and I'm going to get 3x is equal to positive 2. Divide both sides by 3, and x is equal to 2/3. These other ones, they're a lot easier to find. Like, if I set x equal to 0, well, then x is equal to 0. That's the answer. If x minus 1 is equal to 0, then that is 1. If x minus 1 is equal to 0, that also is 1. These are both the same, so it's kind of pointless writing it twice. But those are my 3 answers. My answers are 0, 1, and 2/3. That's 2/3. I could have written it over here, 2/3. So those are the 3 solutions, and I need to order them from least to greatest. So my answers are 0, 2/3, and 1. Final answer. On to number 11. Find the zeros of these functions. Again, zeros means I'm just setting this equal to 0 and then solving. So when I set this equal to 0 now, let's go ahead and find the greatest common factor. I think the greatest common factor here is 3. Does 3 go into 72? Well, 7 plus 2 is 9. Therefore, it is divisible by 3. Let's go ahead and factor out the 3. 3 times x squared minus 5x. And I know that 3 times 20 is 60. And then if I do 72 minus 60, that's 12. That means I need another 3 times 4 to get to 12. So 24 is what happens when I divide 72 by 3. So minus 24. Set that equal to 0. Okay, let's do a normal ninja star on this one. I don't need to do an advanced ninja star since there's no leading coefficient other than 1. Normal ninja star, -5 on the bottom, -24 on the top. What times what is 24? Well, 1 and 24, that doesn't work. 2 and 12, no. 3 and 8, ooh, 3 and 8 I think will work. 3 and 8, let's make the 8 negative, and yeah, that looks like it works. So that means my factored form is 3 times x plus 3 times x minus 8 is equal to 0, and then from there, this x plus 3 is equal to 0, and this x minus 8 is equal to 0. You can rewrite it again if you want. X plus 3 is equal to 0, this x minus 8 is equal to 0, and then therefore x is equal to -3. That's one answer, and add 8 to both sides, x is equal to 8, which is our second answer. Same thing on the next problem. I'm going to set this problem equal to 0 and factor and solve. So if I factor, I'm going to do my ninja star off to the side here. I don't have any greatest common factor, so I can jump right into a ninja star. -4 on the bottom, -32 on the top. What times what is -32? 1 and 32, no. 2 and 16, no. 3, no. 4 and 8, 4 and 8 will give you 4. So 4 and 8, make that a negative. And this is going to be x plus 4 and x minus 8 is equal to 0. That means, again, I'm setting both of these linear factors to 0. So x plus 4 is equal to 0, and x minus 8 is equal to 0. That means x is equal to -4, and x is equal to 8. All right, and then finally, part C, what is the 0 that these two functions have in common? Well, 8. X equals 8. They both have an x equal to 8. All right, on to number 12. If n is an odd number, for what values of n is 2 to the power of n minus 1 a composite number? Explain your reasoning. So, I'm thinking about this problem. If n is an odd number, that means I'm just going to make a table. I think a table is probably the easiest way to do this one. Let's try it. So, here's how my table is going to look. I'm going to have, this is going to be n. I'm going to choose a value for n. And I can only choose odd numbers for n, right? And I'm going to see what happens to the value of 2 to the power of n minus 1. All right, let's try, n has to be an odd number. I'm assuming a positive number too. 1 is an odd number. If I do 1, 2 to the power of 1 is 2. 2 minus 1 is 1. Again, a composite number means it's not prime. So composite numbers like 6 or 9 or 8. A prime number, a non-composite number, is something like 7 or 5 or 13. These are prime numbers. So we're looking for the opposite of a prime number, something that has a factor other than 1 in itself. So 1 is a prime number. Darn. All right, let's try 2. 2 to the power of 2 is 4, minus 1 is 3. Darn, that's still a prime number. Oh wait, that's a bad number because 2 was not odd. We're looking for odd numbers. So let me do 1, 3, 5, 7, 9, 11, 13, 15. I don't know how far we're going to need to go. I should note also that you have a calculator on here, so I might as well just pull that up to show you the quick way of doing this. Let's go to desmos.com/scientific, and when that pops up, I'm just going to do 2 to the power of n minus 1. Hit enter. Huh, nothing happens. And let me zoom in here so that you guys can all see what's happening. Let's say n is equal to 1. Okay, 1. N is equal to 3. Oh, that turns into 7. Swap back over here. That's 7. N is equal to 5. That turns into 31. That's still a prime number. We're looking for a composite number, the opposite of a prime. What happens when I plug in 7? 7 is 63. Ah, whoa, look at that, 63. 63 is 9 times 7. So we have our first composite number. Woohoo! So for what values of n? Well, 7 is one of them. Let's try 9. Oh, wait. Oh, no, I plugged in 6. Darn it. 127. That's still a prime number. God darn it. Oh, 127. No. Okay, well, maybe 9 will work. 511. 511. Is there a quick way to figure out if it's a prime? I'm hearing you say, and the answer is no. In fact, that's something that mathematicians all over the world are trying to figure out. What is a quick way of finding if it's a prime or not? If you find a quick way, please tell me because I need the money. There's some serious moolah behind that. 11 is 2047. 2047. 13 is 8191, 8191. 15 is, oh my god, 32,000. 32,767. 700, oh my god, dyslexic moment. 32767. 767. So it turns out, I did some math off to the side, that 511 is not a prime number. It is a composite number because that's going to be 7 times 23. 2047 is also a composite number because, let's silence that cell phone call, go away. 2047 is also a prime number. That's 23 times 89. And 8,191 is a prime number. 32,767 is a prime number. That is 7 times 4,681. 4,681. And I'm realizing that this is a horrible example to prepare you for the actual benchmark because it's going to be the same. This word is going to switch, though. It's going to be even. And let me give you a hint. If n is even instead of odd, check this out. If you have 2 to the power of, instead of n, let's say 2k, because if I choose k to be 1, this number will always be even, because if I multiply by 2, it's always going to be even, right? So I'm changing this 2k minus 1. Well, this is a difference of squares. That is a square, and that is a square. And you can use the formula that it gave you all the way back here in, I don't know which problem. Where's the problem that has the formula? Oh my gosh, we've done this forever ago. All the way back here in problem 4. So let me just, copy paste this formula down here for us. Scroll down. This is the exact formula that you can apply down here. It's a difference of squares. So if I come and write, okay, this thing is going to be 2 to the power of, well, I have to take the square root of each of them. If I take the square root of this, divide by 2, and that's going to be just k. So 2 to the power of k. Square root 1, that's just 1. So it's going to be 2 to the power of k, 2 to the power of k plus 1 times 2 to the power of k minus 1. This will always be something times something else, which means it will always be composite. Always composite. Because you can always factor it. It's always going to be a difference of squares, and you can always factor it. So the answer here is basically every single number aside from, I think, 2 probably doesn't work. So All values except for the initial value. So if you did it for even values, you'd have 2, 4, 6, etc., and this was 2n minus 1. So 2 to the power of 2 minus 1 is 3. So that's the only one that doesn't work. But everything else does work. So 2 to the power of 4, that's 16 minus 1 is 15. And then to the power of, I'm going to do 6. Let me just switch over here to my calculator. Power of 6, that's 63. And 63 is, again, 7 times 9. So all of these are going to work except for that base case. It's always composite except for that tiny case. So that's what you need to know. And that's what you can kind of explain down below. Well, if you factor, then it's always going to be a product of two factors because it's a difference of squares. You don't have to know that. If you are totally confused on number 12 on the actual benchmark, make a table. You'll get a lot of points for just a table, well, at least half credit, right? Number 13, simplify. So simplify because there's a square root on the bottom. How do I get rid of the square root on the bottom? And this is the way that you don't do it. The way that you don't do it, you say, oh, multiply by the square root of 5 over the square root of 5. That is a good attempt, but not quite. Because if I multiply by the square root of 5, yes, this makes it so it's going to be the square root of 5 quantity squared, which turns into just 5. But then 3 times square root of 5 is 3 root 5, and I don't get rid of the square root. This is how you actually do it. You multiply by the conjugate. The conjugate, again, is the same thing. 3 and square root of 5, but instead of a minus sign, it's a plus sign, and it's 3 plus square root of 5 on the top as well. When I do that, what I'm really doing is I'm making a bunch of area models. Let me make my first area model, and you should be doing this with me. My first area model is 3 minus square root of 5, 3 plus square root of 5. That's going to be, I'll do this in this yellow, 9. This is going to be negative 3 square root of 5. I just ran out of a box right there. That should be all the same box. This is going to be positive 3 square root of 5. Notice those cancel out. And negative square root of 5 times square root of 5 is negative square root of 25, which is equal to the just negative 5. So negative 5 and 9 makes 4. So on the bottom, I'm going to have 4. So my fraction is now 4 on the bottom. Let's do the one on the top. Make it slightly bigger this time. Okay, on the top I'm doing 2 plus 5, 2 plus 5, and on the left-hand side, 3 plus square root of 5, 3 plus square root of 5. This is going to be 6, this is going to be 15, this is going to be 2 root 5, this is going to be 5 root 5. You can combine like terms here to say that this is 6 plus 15, which is 21. This is going to be plus 7 root 5. You can kind of think of the square root of 5 as a variable, and then how many of those square root of 5 do I have? Well, I have 2 here and a 5 here, so 7 total of the square root of 5s. So at the top I have 21 plus 7 square root of 5. That is simplified, but notice that this can be also, it might have a different form, so it can also be 21 over 4 plus 7 square root of 5 over 4. These are the same answers. This one is just broken up into 2 different fractions, so that is also an answer. And we are on to our final problem, looking at first, second, third differences. So we need to figure out what degree this polynomial is. And this is really cool. I wish I could teach this in Khan Academy because I think it's really fascinating. So the general idea is whenever you have constant differences, that is the degree. So let's say like all the differences here were like, I don't know, 2, 2, 2, 2. All of the second differences were 2. That means it's a degree 2 polynomial. If all the first differences are just 1, 1, 1, 1, 1, then it's a degree 1 polynomial. If it's a degree 3, it could be like, I don't know, negative 7, negative 7, negative 7, etc., etc. So we're just going to find the differences. So what is the difference between negative 30 and negative 25? Well, I added 5 to get from 30 to 25, I added 5. To get from 25 to negative 2, I added 23, so plus 23. To get from negative 2 to 45, I had to add 47. And again, you will have a calculator. If I made a mistake on here, and I might, I can always check with the calculator. You will have a calculator for the benchmark. To get to 45 to 122, oh, my math is starting to get not so good. I'm guessing it's 677. Let's test it. 45 plus 77. Yeah, I still got it. So I'm adding 77. You don't have to have the plus signs here. You could just say 77. And to get from 122 to 235, that is going to be 113. I'm adding 113. Okay? Now you do the same thing again. 5 to 23. What do I have to add? Notice that these all are not constant, which is why I'm continuing. 5 plus what is 23? I have to add 18. 23 to get to 47, I have to add, what is that going to be? If I add 7, that gets up to 30. Then I need another 17, so 24. No, that's not right, is it? Yeah, 24. To get from 47 to 77, I have to add 30. And to get from 77 to 113, that's going to be 36. Is that right? Plus 36. I think I did that math right. Okay, these numbers are not the same, so let's go to third differences. That must be the answer, because there's only third differences. There's not a table that goes out to fourth differences. But you could, theoretically, in math, go out that far. 18 to 24, that's plus 6. 24 to 30. Ah, yeah, look at this. Plus 6 and plus 6. Okay, because these are all constants, it must be a degree 3 polynomial. So you can say, let me just type here so I can move a little bit faster. I know that you guys can't do that. Let's say... Let's do this in size, I don't know, 15, is that a better size? This, what is the question asking exactly? Explain what degree. This polynomial be a degree 3 polynomial because all of the third differences were a constant number. And that's as much as you need to say. And that's it. We're done with the practice benchmark packet. I will see you guys tomorrow for the actual benchmark. And as a reminder, Friday is our Thanksgiving. You only spend like 10 minutes after you do your little Thanksgiving dinner in here, and then you go on to 7th period. If you have time to go into 7th period, we might be able to work that out to work more on the benchmark, but try to finish the benchmark all of Thursday. All right, thank you for watching.